Let's do number 14 and 13. Let's start with 13. A local park district is planning to build a recreation center. The park district conducted a poll to find out the types of physical activities the local population would be interested in. The poll was based on telephone responses from 1,013 randomly selected adults. The table shows the percentage of people who expressed interest in various activities. So this is the activity and this is the percent. Notice that the percent isn't equal to 100%. We don't really know why. One of my guesses is probably people decided that when they took the poll that they were going to answer more than one activity. So that might be a reason why the percent is not equal to 100%. Anyway, because we don't even know why it's not equal to 100%, there's just not enough information for this problem. So E is your answer. So anytime you have a table like this that says percent it's not equal to 100%, they don't tell you why it's, well, they don't tell you the reason it's not 100%, then there's not enough information. So 13 is the E. Number 14, it says, suppose X is a variable describing the heights of a group of 200 male professional athletes, half of whom are horse racing jockeys and half of whom are basketball players. Which of the following will be the best description of the distribution of this variable? So X is a variable describing the heights of a group of 200 male professional athletes, right? So we're looking at the average height. Oh, a thing you need to know about horse racing jockeys. They are shorter people, and they're typically shorter because they ride horses a lot faster. I'm not entirely sure why, but if you follow horse racing, you just know horse racing jockeys are shorter. Maybe it's an aerodynamic sort of thing. Basketball players a lot taller. So if you're taking the average height of 200 male professional athletes mixed with racing jockeys and basketball players, you're going to find that the mean of heights are going to have two different peaks, right? And let me show you what it looks like, actually. So you're going to have something like this. You have your average for your jockeys right here, right? And then your average for your basketball players, and then it's skewed to the right. That doesn't really accurately describe the skew. Anyway, let me draw the skewness. Okay. There's my skew. There's my tail to the right. Now, this is mean, correct? This is mean. So take a look at this. This first peak are the mean of the horse race jockeys because their mean height are going to be typically shorter than the mean height of basketball players. The mean height of the basketball players is right here. There's a collection of them that are going to be 6'4" as a height, and then race jockeys 4'4". Now the reason it's skewed to the right because in basketball, you have really tall people that are 7'7", 7'7" and that is a heavy right outlier because there's just not too many people that are that tall. So the collection of most of your basketball players range from 6'4", 6'6", and so that's why you have a mean here. And then your horse racing jockeys, the collection of those people are 4'4". But you don't have a left outlier because you don't typically find horse racing jockeys that are 2 foot tall. Hope that makes sense. That's why there's a right outlier because really, really, really gigantic people do exist and they do play basketball. So 7'7". So for this question, letter D is the answer because the distribution would likely have two peaks and skew to the right, which is what I illustrated here. Again, I hope that's clear. This is horse racing jockeys mean, basketball player mean, and then this is where our outliers are really tall basketball players. But you don't really have really short horse racing jockeys. So they just don't exist for horse racing jockeys. That's 13 and 14. Hope that's clear.